This is the printer bot printing the Z-bearing assembly for baby Huey. This is the last print. There's 4 of these. They take 3.5 hours each. This is sliced to 0.4mm. You can see it's just doing some of the bridging, I think. You can't see that well through the camera. This is about 3/4 of the way through the print, and some of the support material at the back has kind of gone strange, but it shouldn't matter. It's kind of optional. It just stops the PLA sagging as much when it bridges. That's the area there. There's a close-up of that bridging material. The thicker part at the front is also support, and I'll probably thicken the others up to the same thickness. And all my problems seem to have been with the same bridge. Here's a shot from the back of the printer. We're 2 layers away from the bridging for the motor or idler supports. That's the mucky area, and I'll start the camera again when we're bridging. The printer dropped one of the threads going across, so it's going to make a big mess here as it tries to bridge into free space and just drop everything down into the hole. "25 minutes to go." Getting there, up to the layer where we're doing the screw nut holes for the mounting the motors, etc. There's a few problems with my model. Slicer wasn't able to cope with some of the bridging, but it's just cosmetic. The lift point idea worked perfectly. There's a little indentation here, and I got something under that, and it lifted off, and you can see it's come off more or less in one piece. Very little muck remaining. If I get this scraper, hard to do with one hand, but yeah, see, that comes off. That comes off fairly easily, but you got to be careful because the polycarbonate is fairly soft and will cut. This is the SketchUp model of the baby Huey project. That's how things are supposed to go together. So the Z-bearing assembly is here, and the working copy of it is over here. So one of the first things I'll do is fix up that bit of support material. This support material is a bit thin. It's only 0.3 wide. It should still print okay on a 0.5 nozzle, but I'm going to bring it out 0.7mm to make that 1mm wide, and measure that. Yep, 1mm. I work at 1000 to 1 scale, so it actually shows up as a meter, but it's really 1mm.
Now the other problems were in here. I've already added some support material to this piece, and I'll add some support material in here in the form of a couple of thin 0.5mm walls. I won't bore you with the whole process. I'll set up a couple of guides and I'll start the video again when I'm ready. I've set up some guides. So this is 0.5mm by 3mm. So that, I'm not sure that's worked or not. We'll see. Pull this down. No, it's only, I've got a problem in that edge. Okay, I fixed that by deleting an edge in here, and now I'll do a pull down of that shape. Oops, wrong one. That one. And I have to do a control pull down, otherwise it'll stop when it hits here. So control and right down, and I have to go back now and edit all of these overlapping vertices. Will take me 5 or 10 minutes. All fixed and past the solid inspector. I'll just give you a quick look at it in X-ray mode. The motor or idler plates attach here, intended to take a NEMA 17. This is all support material. The two inner ones need to be removed. The outer one can stay there. There are two skate bearings that are held in place by 8mm pins which go through here. The holes for the pins go right through so that you can push the pin out again from the other side if you need to remove it. There are two 12mm rods for the main XY stage assembly. These diamonds are calibration marks to check that the printer is scaled and calibrated correctly. Back here, this is a little dimple to help get the print off the print bed. The print is upside down as you see it. It's normally fitted with the M6 nut down. The M6 nut for the lifting goes in here, and a threaded rod goes through there. I think that just about covers it. The whole assembly rides up and down a 25 or 25.4mm square tube or square shaft. So there are the two bearings run against the square steel or aluminium or whatever it is, and the belt tension from the motors or whatever's fitted in here forces the assembly up against the steel. There's no stability in the other directions. It relies on the other parts being fitted and the threaded rods being fitted to hold everything level. Here is the completed bearing assembly. It's been fitted. It's got an idler there, it's got the stepper motor there, and the threaded rods in here. You can see it basically works, makes it go up and down. The part is a little bit unstable. I don't think that's a problem, but extending it into this space here would make it more rigid without reducing the print area, but that requires a larger printer. So if Huey works as a rep wrap, that may be one of its first jobs. So that's the head assembly, normally driven from both ends, and motor, Z motors, a dummy fitting of the belts. Basically looks like it's going to work. This is the Z motor crown coupling. This is the idler. We're still months away from running, but things are progressing